Hello, my one viewer. Welcome to the stream. Let's give the others around 8 minutes, then we start at 2040 hours. Welcome to the stream, Wayne. Welcome to the stream, man. Let's give the others around 5 minutes now, then we start at 2040 hours. Thank you for joining the stream. Welcome to the stream, Guitar Joseph. Yeah. Today we're going to focus more on now. We want to um, start the training phase, and today we are going to focus more on the data preparation. The data preparation will take a long time, given that the MCV 17 is such a huge data set. Yeah, we might limit it to like a few training rows and validation rows. But yeah, we'll see if the training will start today. If not, today we'll mostly focus on data preparation. Yeah, and we'll write the code for training, and then I'll share the notebook. Then you guys do the whole thing yourself because the data is so huge, man. Thank you for joining, Jacqueline. Thank you for joining. Thank you for joining. Thank you for joining. Yeah. Oh, the type of GPU. No, the type of GPU is not a consideration. Actually, I'll change this to the. I feel like in the. Okay, sorry about this. I was reading. I feel like the requirements is that you use a T4, or I saw my own things. Uh, um, where did I see the T4 thing? I think I saw a T4 rule somewhere. Submissions exceeding the 16 GB limit are removed from top 10 on the private leaderboard prior to evaluation. So I think maybe it's for the inference. Yeah? I think maybe it's for the inference. Or resource restrictions. Your solution must run on a single NVIDIA T4 GPU with 16 GB RAM, such as what is available through Google Colab, free trial. Submission exceeding the 16 GB limits are removed from top 10 on the private leaderboard. Bonus points if your complete pipeline, including speech recognition and text generation, can run within a 4 GB of memory, making it deployable on mobile devices or single-board computers without internet connectivity. Yeah, I think this is only for the inference. Training, you can use whatever GPU you want. I'm not sure though, but yeah, based on this, I can infer that these rules are only for the inference part. But still, I'm going to use T4. Yeah, I'm going to use T4. But even the most part of this stream does not need a GPU, to be honest. Yeah, it doesn't need a GPU. Yeah, so we'll start on a CPU during the data preparation so that we don't waste our GPU compute. And then later, if we get time to train our first NeMo model. Oh, I'm going to focus on NeMo because that is what gave us like a good score. Yeah. Yeah, so last time was fun. Joseph got a cool score. And also I tried, you should also try Whisper. We never tried Whisper baselines, so you can also try Whisper, but the problem with Whisper, it's freaking slow, man. I tried it and it's so slow. So I'm not going to do that on stream. Yeah, you can do that yourself. Yeah. But today we are going to focus on NeMo. NVIDIA NeMo, since that is what gave us a good score. Then we'll prepare baselines for NeMo. I mean training pipeline for NeMo. Then after we finish training and evaluating it, then maybe we'll go to web to vec, do that as well, and compare the two. Yeah. So NeMo data preparation. Yeah. So first you need to, because we want to save this data, we don't want to process this data every time we come like to run this notebook. So we want to save the preprocessed data in our Google Drives. Yeah. And you have to make sure you have like enough compute. I mean, not enough storage. You can see like one of my accounts is like out of storage, but the one we are using on stream, yeah, you have to make sure that you have enough storage. So from Google Colab, import drive. We don't like, we'll use only the CPU for now. Yeah, let's try it using what everyone has. So like NeMo training is actually pretty simple. What you need to know is that you need to have like JSON files stored with the image paths and the transcription. The transcription is the sentence that you like what the audio is saying, and then you have to like load a config, which we'll see, and then we modify that config. Only that. The hard part is the data preparation. Once you get the data preparation right, everything else is simple. Yeah. So we are going to import data. We're going to datasets. From datasets, import load datasets. Load dataset. What else do we need from datasets? What else do you need from datasets? What else do we need from datasets? I feel like that is enough, because I feel like that is enough. We're going to like handle the audio part using sound file, so no need to import the audio we used the other time. This, no need for that. Maybe we'll use it, we don't know. So let's just load it. Obviously we need like a progress bar. What else do we need to access the data? I saw like here this discussion where people were struggling to like load the data, and I think one of the requirements is you have to connect your Hugging Face token. So for that, we import login from Hugging Face Hub. And for us to access our HF token, like I showed you in the other streams, you just come here and add your secrets. So for example, I have HF token right here. And to access this, you can see like this is how you access it. Oh, you cannot see. You cannot see on the stream. I'll show you. You use something called user data. So from Google Colab, import user data. Yeah, I think that's it. And then we log into our Hugging Face now. So how you log in is login token is equal to user data dot get user data dot get HF token, and then you grant access, and you're good to go. And next thing, We'll have our configuration, so we create a configuration class, store our dataset path, which is now MCV17. We're going to then our target language is equals to Swahili, because we don't want to load the whole data. And then our parent path is where you want to save your data. So you can come here, create a new folder, call it anything you want. So I'll call it livestream ASR, and then you create it. Now this is what we'll use to store our data. But since we already like linked our Google Drive, we have to like reconnect to it. So there's this like argument you can do. So this will force remount it, and then we'll access the livestream ASR folder that you have just created. Thank you, my 5 viewers, for joining. Thank you, my 5 viewers, for joining. Yeah, you're not late. We're just getting started. So you come search it here. I can't say mine though. livestream L. Yeah, here you go, and then you copy this. Now this will be your parent path. Now this is what we'll use to this is where we'll store the processed data. Yeah, and then we come to Hugging Face. Hugging Face, search for Mozilla Common Voice. Yeah, Common Voice 17. Wait. Maybe we have more data and we are limiting ourselves. So this was updated 1624. What data did we use in our previous hackathon? Was it 17? Because we don't want to retrieve the same data we used in the previous hackathon. That will be silly. That will be yeah. If it was 17, okay, like it wasn't even specified which data it was. Yeah, okay, Mozilla 17 is okay. So actually it was updated June 16, 2024, and our models that we use as baselines, which we want to like start from there. We don't want to start from the base like CTC. Bro, where is the... Okay, yeah, we had trained those models in 2023. Yeah, so Mozilla Common Voice 17 is okay. Yeah, cool. And I think that's it. Maybe a test index for playing one of the audios. Yeah. Nice. And now, so this, like you see this data, it has like data for a lot of like languages. And the other time I tried to like find if you can see the languages right here, but you have to load for a specific language. Yeah, you can see like languages, yeah. So you have a lot of languages like Azerbaijan, Bazar, Bashkir, etc, and you don't want to load the whole of this data. You're only interested in Swahili. Yeah. and for each language there is an abbreviation. For the Swahili it's SW, and that is what we have like specified here as the target language. Now, also, you don't have to create splits for yourself. They provide you with training and validation splits, and sometimes, not even sometimes, they also provide a test split as well. So, how to know how many splits have been provided? You just come here, call yeah. So we need a function here called get datasets split names. This right here. So get datasets split names, and then you pass in your path, which is here, and also you pass in your config name. Yeah, this right here, and you can read this to like understand what's going on. Like configuration name is the target language, like in a simple term. And also we need to trust. Okay, I'll show you why we need like an error might occur here. It's not an error really. Dataset scripts are no longer supported, but found common voice 17. This was the error, right? This was the error. It seems Hugging Face has a drop support for scripts. Yeah. This was the error. Now we need to like do this or this. Yeah, we need to do this. So we'll just copy this. Yeah. Hopefully it works. Hopefully it works. It starts. Yeah. Nice. It's working. Yeah. So for you not to be prompted, because like for you not to be prompted this, like do you like trust? I mean, contains custom code which must be executed to correctly load the dataset. For you not to do this, you pass in like an argument called trust remote code. Trust remote code is equals to true. And now when we interrupt right now, it will now run without like prompting us for like if we want to like trust the remote code. Yeah. And you can see all the splits that are present. You have train, validation, test. So you don't need to create like the validation set yourself. Like they have already like done that for you. Well, I don't know what all these others mean. Like these other invalidated, validated. I'm not really sure. Yeah. So maybe you can go research more about that. Yeah, and what we are interested today is like the train set and the validation set. Yeah. Now we want to be very economical with our compute. We want to be very economical with our compute. First, we don't need to reprocess everything. We don't need to reprocess everything when we run this notebook. So if you've already saved it in your Google Drive, you don't need to like download the dataset again, etc. So I will first we check. Actually, no. So we need to save the audio files in our Google Drive. So training path is equals to f cfg parent path training. Yeah, that's correct. We don't need the test path. So we check if the training path does not exist. If not, or not validation, then we create them. So we need to like import OS. Yeah, so if they're not present, we create, because the first time you won't have this data. Yeah, and then we now download the data. Train data set is equals to load. We use the load data set, and then we specify the data set path. We specify the target language, and we specify the split, which is equals to train. And then so like in this like suggestion, there was like something streaming is equals to true. I tried that, and it was making my Google Colab to crash. I don't know why. So I'm not going to use it. I'm just going to keep it simple like this. Hopefully it works. And then valid data set is equals to, yeah. Thank you, AI. Now we have to training validation. So I tried this actually, the cast column, and it was giving me errors. I'm not sure why. So I'm not going to try it on stream because, or we can actually try it. So actually, you already know what to do to avoid reprocessing. So I'm going to comment this code. I'm going to comment this code, and then run this, and then run the suggested AI stuff. It was about cast column. Yeah. It was giving me an error. Now I don't know if it will work right now, but let's see. Anyways, when you rerun this notebook again, the right way, it won't like download again because it will be cached in the Hugging Face cache as Google Colab. Yeah. So this takes a while. This will take a while. So as it's running, maybe we should like continue to the other steps. Yeah. So the other step is actually building, like saving the audio files in our Google Drive. So what we'll do is create a function. Then we pass in a data set, which and then we pass in a path, which is a string, and then it actually returns none because we are just building, like we are just saving the audios in our Google Drive. Yeah. Oh, we need to import like data set. Yeah. And then now right now we have not created the training parts where I want to save the audio files. So either way, yeah. If it exists, okay, create the path. If it exists, don't create the path. I mean, don't create the subdirectory. If it doesn't, then create it. It doesn't harm us. And then results is equals to a list. Why are we doing this? It's because we want to like, at the end of it all, we want to like have a data frame with the audio path and sentences instead of doing this as two steps. So actually this returns a data frame. This returns pandas data frame. Yeah, but it also saves the audios in our Google Drive. For item in enumerate to QDM, yes. Audio path is equals to, we want to save it in our path, and we can either use the index, which doesn't hurt, or we can use the if the data has like a record ID or something. Yeah, if the data has a record ID or something, you can use it to like name your audio files. But we actually don't need the file name ID. You know why? Because this is not like linked to the submission file we are supposed to like submit to Zindi. So you can use like a random ID, and it doesn't matter, honestly. It doesn't matter. Yeah. So you have to fix something here. Import pandas as PD. So you can actually use an index, because you don't even know if there is a, maybe there is, but anyway, you do what makes you happy. If saving it to the record ID makes you happy, do that. If it doesn't, if the index makes you happy, do that as well. Yeah, either works. And since we are saving them in like different subdirectories. For example, you're saving the training audios in that training directory, and the validation audios in the validation subdirectory. Yeah, and then you get the sentence. Sentence is the transcription. I mean, the transcribed what the audio is saying. And then if not os.path.exist, we don't want to reprocess an audio that already exists. So audio path, yeah, and then we get the audio array, which is item audio array, and then sample rates. Yeah, the AI knows what to do. But not entirely. Is equal to item audio sampling rates. Now this is the unambiguous, not unambiguous. But if this code doesn't work, this right here, which I doubt it will. Yesterday, like I faced a lot of errors. I tried loading this common voice to like estimate how long the stream will take if you decide to process the whole data, and I was getting errors while using audio. I think something to do with dataset updates, and even like I went to GitHub. People are facing the same issue on Google Colab, and I gave up on it. Now, as a fallback, what I did was I used sound file. You can use sound file to fall back. So how you do this, because you want the sample rate to be like 16K, since CTC models and Web2Vec models are trained using a frequency of 16,000 hertz, we resample it to 16,000. And the audios, if you look at like this discussion right here, they have a sampling rate of 48,000. The LCV 17 Swahili audios, they have a sampling rate of 48,000. We don't need the 48,000. We need to resample it to like 16,000, which like other models have been pre-trained on. The ASR models have been pre-trained on. Maybe you can try like running on like this sampling rate, the default one, but you do you, man. You are free to experiment. If this doesn't give you a good score, you're free to experiment. Now we need some other things. So we need like touch audio, and we need touch. And this will help us in the resampling. Yeah. So this is sample rate, not SR. If sample rate is not 16,000, we need to resample it. So resample, let's see if the AI will know. Resample these using touch audio and touch. Is it doing the right thing? It has to create fast. Yeah, we can try, but sample rates, I feel like no, and we need to create a waveform. We pass in the audio array. Yeah. And then we unsqueeze, and then we resample, and then audio array is equals to waveform, and then audio. Yes. And then now the sampling rates, the new sampling range will be 16,000. And then we save this data. Yeah, I think we are done. Yeah. If you want to save an index, you can do that. Up to you. It's not necessary, really. Yeah, it's not necessary. Oh, we need sound file as well. Yeah, like this data, I mean, the data downloading part is terribly slow, very slow. And yeah, you just need to do this once. You don't, and so like when you're writing your code, you have to be very careful, so that you write, I mean, you write code that won't like force you to download this data again and again and again and again every time you write the notebook. Yeah, but essentially that's what you're supposed to do as we wait for this. It will take a while, honestly. It will take a while. But yeah, that's what you need to do actually. And then so we build our audio files. Training path, validation path, yep. And then we save it. We save it to our Google Drive. Now it will save to like our live stream Google Drive that we created. Yes, I think you're done. This part is done. Yeah? So this part was like building audio files. Next is, as we wait, we cannot even test if the audios are playing. So the next thing, after now you have created the audio files, is to prepare data for like input to the CTC models. And that you need just to create JSON files. It's not like pretty hard. The only thing, it takes a while, but yeah, that's the only block. So here, prepare data in the right format. So build manifest. It takes in the data frame we created and the path where we want to store the manifest. And the path we need to store the manifest is actually training manifest path is equals to AI do something for me. Yeah. So these are the parts you pass. Actually, it's not like it's not like CSV. We need a JSON. We need JSON, bro. We need JSON. Yeah. And then, yeah. Honestly, it's. I feel like, yeah. This part is not hard. Honestly, like training CTC model is pretty easy. Maybe you get dependencies issues in that are that are that are hard to like fix, but like the whole process is actually pretty easy. The data preparation step is where you need to like get it right. We look through the data frame. This is not manifest path, but rather path as right as F. Yeah, come on AI, do something for me. Audio path, we need the audio path, we need the sentence. Yeah, good AI, good AI. And now we need to process the sentence by making it lowercase and stripping off white spaces. So lower dot strip. Nice. AI do something for me. So yeah, the audio part. Uh, yeah, yeah. I think yeah, that's correct. That's correct. That's correct. We need to import JSON as well. Bro, this will take a while, man. This will take a while. We are still at the train data set. You see, like this green thing right here, and we still have to process the valid data set. But anyways, JSON the dumps audio file path. Okay. You don't need to return anything. We just need to build the manifest. Audio file path, text. Yeah, we don't need to return. We don't need to return anything though. Do we need? We don't need to return anything. We don't need to return anything. You don't need to return anything. Yeah. So chain valid, chain a manifest path. So it's very hard to like test it until like this finishes. Yeah. So we are just hoping we are doing the right thing. And now the CTC specific thing. So if you come to like Google and search how to fine tune how CTC models using NVIDIA NeMo. Actually, you know how to fine tune CTC ASR models because yes, yeah. Fine tuning CTC, you have to download the data. Uh, Python convert HF dataset to NeMo.py. Yeah, so you have a manifest file. You have a manifest file for the train, dev, and test. And then you prepared the dataset for training. Um, Read manifest, character sets. Get character sets, count the number of unique tokens that exist, etc. Okay, this they did too much. You don't need to do all this. Maybe you need to do, but yeah, you can go check this out. Honestly, we will not do all that. We'll just create a simple baseline that works. Hopefully, hopefully it works. um, Process data set, final character set, update the vocabulary, update config. Yeah, so this is what you're interested in. So each NeMo model has a config embedded in it, which can be accessed via model.cfg. In general, this is the config that was used to construct the model. For pre-trained models, this config generally represents the configuration used to construct the model when it was trained. A nice benefit to this embedded config is that you can repurpose it to set up new data loaders, optimizers, schedulers, and even data augmentation. So that is what you're trying to do. Set up new data loaders, optimizers, and schedulers. Data augmentation, not today. Yeah. So I feel like this was only specific to Japanese, like updating the character set of the model, etc. I'm not really sure though, but you can go check. I've linked the notebook on the charts. Yeah, and then you set up the data loaders, you set up the optimizers, set up augment. Oh, there's also like maybe I need to read this notebook. I never. Okay, I've never gone through this. So I don't even know how to create augmentation for STT models. So for low resource languages, it may be better to increase augmentation via spec augment to reduce overfitting. Nice. Nice. However, this might in turn make it too hard for the model to train in a short number of efforts. Okay. So you can also set up the metrics, set up the trainer, which uses PyTorch Lightning, by the way. So we need to like import PyTorch Lightning as well, and then we use PyTorch Lightning, and then yeah, the results. So hopefully we get to do all this today in today's stream. If this finishes, if this finishes early, yeah. But the hard part is the data preparation. If we successfully do the data preparation, then it will be easy. It will be easy. So we load configurations. From Romel, that's YAML, imports YAML, and then config path, yeah. So this is where your config path will be saved, and then if you check if it doesn't exist, if it doesn't exist, first create a directory for the config path, and then now these, if you come to, let's see what they used. When was this published? 8 months ago. Okay. Yeah, maybe we should follow this. Maybe we should follow this, but I need to like go through it maybe in tomorrow's stream. But right now I'm going to use my older one. I'm going to use my older one. ASR project. So if you never like check these out, please do. It has both, so you can have a head start. It has both Web2Vec and that NVIDIA NeMo. So the only thing that can go wrong is if the dependencies are deprecated. That's the only thing that can go wrong. Yeah. So I'm not really sure. We will know. We will know. We will know. We will know. We will know very soon. Very soon. Yeah. This is what I want. Actually, everything here. No. Forgive me. I was young, man. That is even embarrassing to show on stream. But yeah. We just need. Oh, we need all these here. We need from there. Yes. We need everything from there. In branch main config path. Yeah. So like I feel like these parts needs us to like have them everything loaded for us to like, because I honestly don't know if this will work. This was 2 years ago. I don't know if it will work or not. But yeah. Yeah, this is taking a lot of time. I wish I had done this before the stream. My bad, my bad, my bad. Tomorrow I'll come better prepared because we'll have the data in our Google Drive, so it will be easy. So this is like the model configurations, and we need to modify it. Remember the article said we need to like modify the data loaders, optimizers, all that. This is what we are going to do here. So the params which we loaded, model, yeah, AI, thank you. So we trained yes manifest file path is equals to training manifest path. A validation data set, yeah, and then params model. We actually don't need the tests right now. We only need those two, and then params. Now this is the data loader part. This is the model, training configuration, for example, the batch size, etc. Yeah, train data sets, batch size, is equals to 12. Yeah, I think that's it. Epochs 12, no, 15, maybe. But this you don't need to set, like it will be handled by PyTorch Lightning, so we don't need that. Yeah, I think that's it. That's it. No, we need to like modify the optimizer as well. So new optimizer is equals to copy dot do copy. Oh, it's done, it's done, it's done. It's done finally. It's done finally. It's done finally. Yeah. It's done. It's done. It's actually done. Wait. It has not drawn an error. Are you kidding me? String to set 0 or so we have an audio. We just want to check the audio. Yeah, I feel like this is a much better. Okay, not this one, but the ones we were looking at. Yeah, this was updated months ago. I need to like go through this notebook again. Yeah. Nice. You can see that everything it talks about, like the sampling rates. For example, the sampling rate is 48,000. We need to resample that to 16K. You need to resample this to 16K, and then you have the array and you have the audio pads in the cache. Now, oh, we need to load. I mean, a lot of things we imported, new things, so we need to like, bro, SF man. Yeah. So here we build our audio files. This won't take a lot of time. Like, yeah, chain valid, everything is okay. Is everything okay, really? I had not specified that. I had. Yeah, we're supposed to use these training part and validation part. I'm not. Okay. Oh, I see. This is the data set. Train data set, valid data set. Yeah. Okay, everything is okay. What? Like it's supposed to build the audio files, bro. If not OS file. Bro. Are you kidding me, bro? Hey, nashangaa mazi. Nice. Now everything is okay. This won't take a long time. The one which will take a long time is maybe this. Yeah, we'll see. Yeah, so our live stream ASR, you can see we are getting the audio files.
Macho yangu yamefungwa.
And you can play them.
Macho yangu yamefungwa. Utaona umebadilisha kauli na sasa wataanza kumuunga mkono kwa hivyo.
Yeah, they're okay. So yeah, they're okay. You can see like it's like 46,000 audio files. Man, yeah. Yeah. We need to like fix this. We need to like fix this, bro. Okay, it's only today. It's only today. So like to avoid this issue again, yeah? To avoid this issue again, we'll just say if os.path and os.yeah, they do not exist, then do all this step. But if they exist, then you don't need to do this. You just need to load the data. Yeah? Now every time and actually, even this, bro, even this, we don't have to like download this every now and then. So we need to like add this to our loop right here. You only download if you're making those data sets. Yeah. And this actually, it's not if os.path exists. No, it's if not, and not as well, and not os.path get path exists, then download the data sets, and then build the audio files, and then build the the data frame. Yeah, with that, we don't need this anymore. So we can comment this out. We don't need this. We need the training parts, the validation parts. Yeah, training part, validation part. Yeah, we need that. Yeah, and even this, I feel like, yeah, even this needs to change a bit, a bit. Yeah, this needs to change a bit, because we don't need to build a manifest every time we run this notebook. Yeah, yeah. So, Kwanza, since like it takes a very long time, you can, let me return the music. You can process up to like 10,000 and then break it. But then when you come to process it again, then that means, then that means, it will start from zero, but you don't want such a scenario. So how do you like save yourself from this? So we'll load if there's an existing manifest, so we'll load an existing manifest. If that manifest exists, we load it, and then we check. We actually check, yeah. If os.path, if not, if it doesn't exist, we don't need to return a list though, we need a set. And then with open manifest path as file, then this will change a bit. Return json.loud line audio file for line in f in yeah. And then we check here for the processed files is equals to load existing, and then it will return a set of all the processed existing files. And now this will this will change a bit. So we open in append mode. I think the AI will pick this up now. Yeah, we open in append mode. Let's strip. If audio path continue. Yeah, and I think that's it. That's it. Now even if like now if they exist, it will pick up from where it left. Yeah. Load configurations. Okay, this is going to take a while. This is going to take a while. So I feel like we should start, because like for you to understand this part, we have to see it in action. And maybe I don't even know if the libraries have been deprecated or not. So until all these are done, I feel like we cannot continue on stream. Yeah, I feel like we cannot continue on stream. How does one like get rid of spam messages? Okay. Yeah. So I will NeMo data preparation. Okay, everything from here. I think we'll do them tomorrow. Everything from here we'll do them tomorrow. Yeah, because we cannot continue, honestly. We cannot continue without seeing what's happening. Maybe we limit the training data to like we limit the training data to like 10,000 versus like validation 2,000. Then we do it on stream, or we wait for tomorrow. We wait for tomorrow. We wait for tomorrow. Then yeah, because by tomorrow I'll leave this running during the night, and then yeah, tomorrow we'll continue from here. Now it will be the modeling phase. Then we can call this stream data preparation. Yeah. Yeah. So training manifest. Yeah, I'll save it. But we still have like we still have like we still have like 20 minutes more remaining. What do you think? Tell me on the chats, my two viewers. What do you think, man? What do you think? Because now, what do you think, guys? What do you think, guys? Also, maybe I'll go read this. I'll go. This looks so modern. Are they even using Python Lightning? Yeah, they are. They are. Maybe I'll go read about these and see if there's some things I need to add in my previous notebook on GitHub. Yeah. Or we can work with samples. Okay, Joseph. Let's work with samples. I feel like now that we have for nearly 14,000, we can break this, interrupt execution. Yeah. But now we need the pandas data frame, bro. We need the pandas data frame. Damn. We should be saving this data frame in progress, like yeah, we should be saving these data sets in progress. Let me use AI, man. Let me use AI. Because now when you break it, when you interrupt it, the data frame has not been built yet. We need to save like this data set while creating the audio. So that when an audio is saved, then the data frame is also saved. But we can give a buffer of like 100 audios and then save the data frame after the 100 audios. Let me ask Gemini. But either way, we won't have time to finish. We have like how many minutes? 18. Yeah. Joseph, I'm really sorry. I don't think we'll even get to the training itself, because after this was just building the audio files. Remember, we have to build the manifests. You have to build the manifests themselves. So my advice is for us to continue with this. I'll make sure the dataset notebook is updated before like pushing the video on YouTube, so that you guys can also run it. And then tomorrow we start on the modeling phase. Yeah, Tomorrow we start on the independently phase. We've got no hurry, bro. We got no hurry. I mean, this competition runs for like 2 months. Runs for like 2 months. So actually, you can even go to GitHub and try the notebook yourself. Now that you already know how to make the data. But yeah, I feel like I need to go through this and see what's new for me to add in my training notebook, and then yeah, tomorrow we start the modeling phase. Yeah. So yeah. Um, thank you, Gitao. Thank you, Gitao. Thank you for understanding. Also, to be honest, I never wanted to extend it. I never wanted to extend today. Let me just make sure this is training part. Yeah, I feel like now that's okay. Uh, Chain data set. Yeah. I feel like that's okay. This is okay. Yeah. Also, I never wanted to extend because today is a very interesting. Let me just ask. Can I show YouTube? I don't want to be banned or something. There's a very interesting chess match going on right now. That okay. I think we can. I think we can. So there's a very interesting chess challenge going on of the big LLMs going head to head, man. I feel like that's so interesting. Uh, yeah. Yes, sir. Yes, sir. Right now it's Gemini versus Cloud. Gemini versus Cloud. Go watch this stream, man. It's pretty interesting. So with that, I call it a night. Yeah, tomorrow we'll start the modeling phase. Thank you for joining. I really appreciate it. I'll see you tomorrow, guys. And if you're not following me on Twitch, follow me on Twitch. If you're not subscribed to my YouTube channel, please do. Bye.